Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Hello, pinang kita dengar ni. Assalamualaikum.
Waalaikumsalam.
Okay, good. Patutlah saya tak dengar. Tak pakai benda ni. Okay, before we start. Okay, anything from last class? Anything or any question from last week? Okay, all right. So in that case, we will continue from where we left on Wednesday on the subject of inequality. So I will continue from there. Now go back to Wednesday. We were talking about how to determine an inequality. And the method we were using is by graphical method. So this is where we left last time. We have a test point. Now a very simple test point, like I mentioned earlier, is 0, 0. So we test that point and see whether does the point satisfy that inequality. So I think that is where we left last time. Okay, so I think we did one test point, and that test point does satisfy the inequality. So if that test point, okay, satisfy the inequality, then all the points on the same side as the test point will also satisfy the inequality. So therefore, all the points, okay, would be the inequality. So I think I will conclude here. So therefore, all those points form the inequality. All those points on the same side, all right? And how do you show it? We just shade, okay? Shade the region. So it is a whole area, okay? It's half the page. So actually, it's actually half, okay? Half the graph. Either on the top of the line or the bottom of the line. So if you go back to the graph, either I say here is on the top, above, or below, okay? Or either under or above, below or above, or what else? Is there any other term? Above or below, or up or down, all right? So either you have above or below, or it's up or down. All right, so we did that. So that is the what do you call it? How do we determine the inequality? We just take a test point. So that is case number 1. Okay. Now, suppose, all right, we take a second possibility. Now, suppose you take a test point. Suppose the test point that we use, we take, okay, the test point that you test does not satisfy. It doesn't satisfy the inequality. Then, okay, then we say that all the points, okay, all the other points, all the points on the same side, okay, on the same side, as the test point does not or do not satisfy. The test point will not or don't or don't satisfy. Okay, don't satisfy the inequality. So if one point, the test point does not satisfy, in other words, all the points will not satisfy. All the points on the same side will not satisfy. Just like if the test point satisfy, then all the points on the same side will also satisfy. So reversely or conversely, if the test point does not satisfy, then all the points on the same side as the test point will not satisfy or do not satisfy that inequality. Okay, all right. So therefore, we don't have to test another point. Okay, so therefore, where is the inequality? So all the points, there are only two possibilities. Okay, either satisfy or don't satisfy. If, let's say, the same side as the test point do not satisfy, then what? Then all the points, the other side. Okay, the other side of the test point. Of the test point from the line. Okay, from the line will satisfy. So you don't have to. So you don't have to test another point. We just conclude that the points on the other side will satisfy. Okay. So if the test point do not satisfy, then what? Then the inequality would be the other side. Okay, the other side. So it's very easy. So you don't have to test many 2 points. If the test point is satisfied, well and good, because that will be the area. If the test point does not satisfy, then what? Then the other side will satisfy. Okay. All right. So let's look at an example. Suppose you take a test point 0, 0. All right. So 0, 0, as you can see from our example, is where is our inequality? Our inequality is 2x plus 5y less what do you call it? Bigger or equal to 25, right? All right. So when you take a test point 0, 0, we substitute, you get 0. And 0 does not satisfy the inequality. So here doesn't satisfy. Because 0 is not bigger than 25. In fact, 0 is less than 25. So that 0, 0 does not satisfy. So what is our conclusion? Our conclusion would be the inequality will be what? Will be all the points. There will be all the points on the other side. On the other side of the equation. Okay, so go back to the graph. So I go back to the graph, we have, that point that we test, 0, 0 does not satisfy. So what does it mean? It means all the points on the same side do not satisfy. Therefore, where is the inequality? The inequality will be the other side. So the other side will be near. Okay, will be this side. Right. Is there any question on this one? Okay, good. All right. Because you need to test only one point. Okay, if that point satisfies, that's good. If the point does not satisfy, that means the other side will. Okay, I'll give you another example. So I'll give you a second example. We have 2x plus 5y. All right, I'll give you another one. So example number 2. Okay, this one I want you to do it. Okay, I give you 3 minutes because by now, we can draw quickly, you get a test point. So let's say I have 5x minus 7y less or equal to 80. All right, I want you to draw the inequality. You can draw on the same graph, okay, as the example. So draw that inequality. Now, test point, use 0, 0. Okay, just use 0, 0. Okay, do it now. Okay, you got it? Okay, what is the x-intercept? So number 1, you get the equation. All right. So you get the intercepts. Okay. So you show the work. Okay. But here we just want to save time since you already did it. So x-intercept, Papa?
16.
16, 0. Is that right? Everybody get 16, 0? Okay. Y-intercept. Okay.
Yes.
Y-intercept, Papa? Y-intercept 0. Negative
11.43.
11.3. Give me another point. 3, 3. Yeah? Okay. So you have these 2 points. 16, 0, 11.33. So what you do here, we draw that inequality. So we can put it on the same graph, okay, as our first example that I did. So I go back to the graph. So we plot the inequality, or, firstly, of course, we plot the line. And that is, lambat ni graph ni mana pergi? Okay, here. So we have 2 points. The x-intercept is 16, 0, be somewhere here. And then the y-intercept is 0, negative 11.3, be somewhere here. So what we do, we, of course, that is the straight line. We will connect the 2 points. So you label the line. Okay, first thing that we do, label the line. This is 5x minus 7y equal 80. All right, so that's the line. Now what you want is less or equal to. So we take a test point 0, 0. So of course you can do a test point other than 0, 0. But 0, 0 is a very convenient point. So take test point 0, 0. So number 2, you take a test point, 0, 0, and then you do by substitution. We have what? 5 times 0 minus 7 times 0. That is equal to 0. And 0 is less than 80. So that point satisfies. Okay, so that point does satisfy the inequality. So therefore, all the points on the same side as 0, 0 will satisfy. So what you do, you will just say that this point satisfies. So therefore, all the other points on the same side will also satisfy. Hence, our inequality will be every point on that side. Okay, so that is the inequality, and that inequality is 5x minus 7y less or equal to 80. So first you label the line. Okay, after you shade the area for the inequality, then you have also to indicate that the shaded area is the particular inequality. Okay, all right, any question? Okay, good. So I think we have done enough inequality. Now the second case, all right, second case, we might have strict inequality. When we say strict inequality, that means you have only the equal. You don't have only the bigger or less than sign. We don't have the equal sign. So that means, you know, will be what do you call it? Will not include the points on the line. Okay, that means it will not include the equation. It only includes the inequality. So if you have a strict inequality, say bigger than or less than, then what you have is that everything, okay, the inequality is still the same. What you have will be minus, okay? What you have will be minus all the points on the equation. All the points on the equation will be not included. In other words, all the points on the equation or on the line will be excluded. All right. Now, how do you draw it? The method is still the same. Okay. Method is still the same. It's just that you have to exclude all the points on the line. Okay. So how do you exclude? We exclude by doing the broken line. So the equation line, you break it. Okay. We break. So in other words, it will be like this. If the line, say the line is like that, okay, let's say this is ax plus by equals c. So to indicate the strict inequality, either bigger than or less than, what we do is we simply show the break line. So you just break the line. So you don't show a continuous line, you show break like this. So that's how we do it. Because the points on that line, on the equation, is excluded, do not belong to the inequality. Okay, all the method will be the same. Okay, the method will be the same. You start with the equation, so method will be the same. That means you start with equation, okay, except that the line you just show it by broken line to indicate they don't belong to the inequality. Okay, any question on that one? So for example, if I go back to my graph, if one of the inequality, just a strict inequalities, just example, right? Because I just want to draw I don't want to draw another graph. I just make use of what we have here. Now, suppose the area or the inequality 5x, 2x plus 5y. Suppose, all right? I'm not saying it is what you have in the example, just suppose. Let's say you have 2x plus 5y bigger than. So let's say I have 2x plus 5y bigger than 25. So everything you do is the same. Okay, what is the difference? The difference will be it does not include all the points on the line. So therefore, you show it by broken line for that particular equation. Okay, that's like that. So that is how you show a strict inequality. So when you see a broken line for that inequality, that means the equation is not included. All right, it is a strict inequality. Okay. All right. Any question? Okay, good. So therefore, that is how you draw the inequality, strict inequality. Okay, next. Next, we're going to look at a system of inequality. Just like a system of equation. So a system of inequalities is where you have two or more inequalities at the same time. All right. You have two or more. So in other words, you want to find the solution to the system. Now, how do you find the solution to the system? Now, we are doing it here, okay, by graphical method. So we just use the graph. So that's why drawing the graph for inequalities are important. Graphical method, that means you just do it by observation. Okay, you just observe and then identify. So that is the method. So what you do is this. Number one is doing what we have been doing. All right. So you need to draw all the inequalities. Not each, I think use the word all inequalities on the same graph. Okay, on the same graph. Now, what is the solution? The solution would be the intersecting area. Okay, the intersecting area or region or common. Okay, common area, or sometimes we call it feasible region. Okay, it's a feasible region. So feasible region, short form FR, common area CA. So it's a common area or intersecting area. So that is the region or the area that satisfy. Okay, that is the area that satisfy all the inequalities. All inequalities in the system. All inequalities are, so I do that. All inequalities in the system at the same time. But that's why we call it common area. So you just observe, okay, and see what is the common intersecting area. That will be the solution. So the solution will be many points. In fact, if you look at real numbers, there will be infinitely many points. So it will be many points because in a region there are many points, or there is no solution. Okay, so either you have a solution, it's an area, or there is no solution. That means there is no intersecting area. Okay, any question about that? So what you do, okay, you draw all the graphs on the same line. You draw all the inequalities on the same graph, and then you identify the common area or the feasible region, intersecting area. That means the area that satisfy all the inequalities in the system at the same time. Okay, all right. So either you have an area or there is no solution. No solution meaning there will be no intersection area between the two inequalities, or two or more, or all inequalities in the system. Okay, all right. Any question? Okay. So let's go back to our example. You go back to our example. If you look at the graph, you'll see. Okay, first I will write down the system. So a system of inequalities will be something like this. The inequalities. Let's say I have two. Okay, two inequalities. Of course, it can be more. You have a1x plus b1y, say bigger or equal to c, called c1. So that is number one. And then you have a2x plus b2y less or equal to c2. So that is number two. So you have two inequalities. Or if you have three, okay, you have three, then you have another one. So we call it a3x plus b3y bigger or equal to c3. Then you have three. So you draw everything here on the same graph. Okay, same graph. And then what do we do? You identify the common area. All right? Identify the common area. So that will be the solution, or we call it feasible region. Okay? All right. So you may have two, you may have three, you may have four, regardless, whatever it is, as long as be two or more. All right? So you can have three, you can have four, or more. But for us, okay, for us, either we normally we will encounter either two or three, all right, because that is manageable. You draw the graph. We don't consider four, all right. But it is, there are systems with more number of inequalities. So that is a system, and the method that we want to determine the solution is by the graph method. So let's look at an example. Example is the one that you are doing earlier. I mean, the example that I was looking at. So example, I want you to go back to my graph. There are two inequalities. So I want you to write down all those inequalities. System of inequalities. So write down the inequalities based on the graph that I just draw. And then you find the common area. So go back to the graph and identify the inequalities. What are they? Okay, wait. Okay, what are the inequalities in the system? Based on my example that we have here, I have 5x minus 7y . 5x minus 7y less or equal to 80. So label it as number one. And then I have the other one is 2x minus, actually 5y, bigger equal to 25. Okay, so call it number two. So that is the system. Okay, so now you go back to the graph, because I just want us to look at the graph, because we already have the graph. So we draw it already on the same graph. And the broken line is no more. So the broken line is just to indicate straight inequality. Now we have We don't have any more breaking line. The line will be continuous. Okay, right. So, can you identify the common area? Where is our common area? That means the region intersecting all the inequalities. Is there an intersecting area or there is none?
There is.
There is. Where is the area?
Where
If you look,
the black and red shaded
the black and the red, okay? The overriding or the intersecting between the region red and the region black. So if you look at that graph, will be the area that is bordered by this line, the black line, 2x plus 5y equal to 25, up to that point where it intersects the other equation. And then from there, it will be bordered by the other line, which is 5x minus 7y equal to 80. So therefore, the area above this one, okay, above the line, we call it feasible region or common area. So label the area FR. Okay. Any question on that one? So very easy. Okay. Why? Because it's just based on observation. So the key here is drawing the inequality correctly. If you draw it wrongly, that means you will get the wrong solution. A feasible region that is not the solution. So therefore, everything will be not correct. Okay. So the key here is drawing it correctly. So once you've got that feasible region, that will be the solution. Okay, we are done. Now, there are two types of feasible region. If you look at this feasible region, how big is the area here? How big is it? If you look at this region, it will be what? It will be very big.
Yeah.
Because it is open area. So if you look at this point, this region here, it is open. Or you call it unbounded. Okay, unbounded feasible region. Why unbounded? Because it is not the what do you call it? There is no boundary on one side. Okay, so you will see it is open. It can go all the way to the planet Mars. All right, it's open all the way. You see, so you have so many infinitely many points. So unbounded means it is unbounded, no boundary. Okay, unbounded, at least one side, at least on one side. So at least one side is open. Okay, so if you don't have a specific shape. If it is a specific shape, then it can be in a triangle, rectangular shape, you know, or cylindrical shape. But here, you cannot identify the shape. It's open, all right? So it is unbounded at least on one side. Okay, on one side, it is bounded. So we call this unbounded feasible region. Okay, all right. So the other type of feasible region is called the bounded feasible region. Okay, the bounded feasible region, meaning if I have a bounded feasible region, that means it is closed. You have boundaries. Okay, you have boundaries all sides. In other words, it's a proper shape. You know, it can be like a rectangle or triangular shape, things like that. Okay. So in order to establish that, I introduce another inequality. Let's say we have x less or equal to 30. So I want you to go back to the graph, put in this inequality, okay, call it number 3, and see what is the feasible region that you get, and how is it different than the one that you got earlier when you have only 1 and 2. Okay, go back to the graph and see the feasible region. Wait. It shouldn't be X, it shouldn't be X. It is Y. If it is Y, then is it horizontal or vertical line? Kalau Y equal to 30. Actually, it is Y, not X. Sometimes, whether that horizontal line, vertical line, sometimes can be confusing. No? So is it the X or is it the Y? Okay, now y equal to 30, the equation. Well, how is it? Is it the vertical line or is it the horizontal line?
Horizontal.
Y equal to 30 is the horizontal line. Okay. So here y equal to 30. That means all the x, all the x will map to 30. So everything maps to 30. So it is a function. On the other hand, if I have x equal to 30, what is the line? Vertical or horizontal?
Vertical.
Vertical. Okay, this is not a function. Okay, this is not a function. Why? Because x equal to 30, it maps to every value of y. So it does not satisfy the function. So this is not a function. So that's why you have here just a system of inequalities. Because sometimes, your linear function, your linear equation may not be a function. All right. So example is x. So let's go back to the graph. We have already determined that y equal to 30 is the horizontal line. So we just include that. You have less or equal to. So 30, you got 5, 10. Okay, if I go by scale, it will go up there. I am out of space. So what I do, I put 30 here. Senang cerita. So that is, itu according to scale. Tukar. I think, apa dia? What did you say? I think I'm going to change the number so that will be clear on my graph. So I just use 10. Okay. If your graph 30 can fit your page, that's fine. But my graph doesn't fit. So therefore I change the number, I put it 10. So 30 ini tak betul. Correct? Because I put 30 will be up all the way up there. So I put 10, so that will be shown clearly here. So y equal to 10 is the horizontal line. So that is the line. So you label here y equal to 10. Okay. Now y less or equal to 10 or y less than 10, that will be what? That will be the area below the line. So that is the area here. Okay. Now, what is the difference between the feasible region when you have 3 inequalities than the feasible region in the earlier example? What is the difference?
It's bounded.
The feasible region now is bounded. So that is your feasible region. See here, it's a proper shape bounded by this line. Y equal to 10 and that line up to here. So it is a rectangular shape. Okay, it's not rectangle, I'm sorry. It is a triangle. So that is bounded. So the two types, of solution, either it's unbounded or bounded. Okay, all right. So a system of inequalities is where you have a situation of 2 or more inequalities. And then what we want to do is we want to find the solution. So I will give you another example. Okay, this one I want you to do. So go to example exercise. Exercise 4.1. Okay, exercise 4.1. I would like you to do one example here. Okay, we just do the one that involves 2 inequalities. I'll give you the questions on the 3 inequalities later on when you can do it at home. So let's see. Saya cari dulu mana yang bagus soalan ni. Okay, you go to question number 25. Okay, look at question number 25. Sekejap. Okay, bolehlah. Number 25. Okay, number 25. You just draw the two inequalities. The x bigger equal to 0, y bigger equal to 0. For now, take it out. All right? Just consider the two inequalities. Okay. Do it now. Okay, I want you to draw it on a graph. Same graph, and then show me the receivable result. Okay, do it in 5 minutes. Oh, yeah. You know, that question number 25, if you have a different addition, probably, you know, it's different number. Yang, the one with the equation x plus 2y, okay? Bigger or equal to 20. So that is, if you have a different number, you know, then do a different number, but the inequality, the first inequality is this one. Sometimes, you know, it is good that if you turn on your video, because at least I can see what you're doing. Like, I think this one, you know, so far I have only one student. Sharifah je dengan ni, Tafani. You know, so maybe if you turn on your video, at least I can see, you can show me your work, you know, sometimes. Once if you do the work, you can show me what you have done, you know. So this is good. Turn on the video, because I don't off your video. Actually, I turn it on. I do not know, you know, somebody just attend and then they go out and drink coffee with your mom. So I don't know whether you are here or you are not here. Okay, dah dapat dah. Anybody get the inequality? I mean, non-equality, the feasible region? Okay, you got it. So let's. I think by now you're already drawing. So let us review. Okay, I will go through this. So you draw the equations. So first, the equations are okay, x plus 2y equal to 20. Now, what is the x-intercept? X-intercept, I want you to show the work, okay? Y equal to 0. Then you have what? Then I have x equal to 20. So now, take the point. The point is 20, 0. So specify that point. Don't just stop here, okay? Write down the point, okay, 20, 0. And then you got the y-intercept. What is it? X equal to 0. You have 2y equal to 20, y equal to 10. So now you have the y-intercept, 10. So what is the point? The point is 0, 10. So again, write down the point, okay? So now people tend to do mistake here. You take y equal to 20, x equal to 10, and then the point will be 20, 10. Okay, that is wrong. The point is not 20, 10. There are 2 points, okay? 2 points. One is the x-intercept, 20, 0. The y-intercept, 0, 10. You just don't combine the value x and the value y, you get that point. So that is not right, okay? So there are 2 points, x-intercept, y-intercept. Everybody got this?
Yes.
Okay, good. All right. So for the second inequality, you have what? I have, mana dia tadi? Negative 3x plus 2y equal to 4. Less or equal to 4. So what are the x-intercept? I want you to work it out. Okay, I will just show you the intercept here. The x-intercept will be negative 1.330. What is the y-intercept? 0, 2. So these are for the second inequality. And now, what scale do you use? Because here, very strict, very contrast. For the one equation, you have 10 and 20. For the other one, is very small, 2 and 1.33. So what scale did you use? I'm just asking, what scale are you using?
5.
So most people use 5, okay? Anybody do not use 5? Anybody use another scale?
I used to.
If you use 2, your graph will be very big. You can use 2, but then the graph is very big because you have up to 20, the value of y. So I agree with you. If you use 5, that will be just reasonable. Okay, if you use 10, too small because you have here negative 1.33. But you can use 2 or you can use 3. I think the most reasonable one would be 5. Okay, so your graph will not be very big. And if you use 10, it will be too small. So what you do here is, let's say we use 5 and 5, and you have that negative value. So when you do this, for the inequalities, it's good that you put it somewhere in the middle, because it will include some negative values and some positive values. So use 5 and 5. Let's say here 5, 10, 15, 20. Or you can use 10. And then here is negative 5. Similarly here, 5, 10, 15, 20. This is negative 5. All right. So have you got the inequalities yet? So for the first one, I have 20, 0. 20, 0 be somewhere here. And then the other one is 0, 10. 10 over here. So that is the line. It's a straight line for that equation. So you connect the 2 lines. Okay, I missed that point. Okay, so make sure you will run across that point 20. Okay, but I'm not going to redraw it. So I assume that is 20. So make 20. So this is the line x plus 2y equal 20. So label it. Okay, all right. Now test point. you take 0, 0. Okay, take 0, 0 here. Because from now on, I recommend you 0, 0. So when I do test point, I will just take 0, 0. So if I take 0, 0, I don't think I have some space over here. So I take point 0, 0. So I have here x plus 2y, all right, bigger or equal to 20. Now test point 0, 0. Okay, so substitute. What do I get? I get 0 plus 2, 0 equal to 0. Now, 0, is it bigger than 20? It is not. Okay, it is not. In fact, it's less than 20. So, all the points on the same side of 0, 0 do not satisfy. So, therefore, where is our inequality?
On the other side.
The other side. Okay, so points on the other side. You don't have to write lah. Okay, you don't have to cite. You don't have to write on the side of the equation. You don't have to write here. Okay, you just show it on the graph. So you do the test point, doesn't satisfy. That means will be the point on the other side. So therefore will be those area. Okay, everybody good? Got that? So label here 2x. I'm sorry. X plus 2y bigger or equal to 20. So that is our inequality number 1. Now for inequality number 2, I have the y-intercept negative 1.33 be somewhere here. And then the y-intercept be 0, 2 be somewhere there. I think it should be there. So connect the 2 points. I have that point. All right. So you label the graph. This is what? This is negative 3x plus 2y equal 4. All right. We want what? I want less or equal to which side of the line, up or down?
Down.
You test with 0, 0 again, okay? Because test point consistent, 0, 0. So you test with 0, 0, you will see that 0, 0 satisfy that inequality. So therefore, we just the same side as 0, 0 will be what? Will be down. Now, if you don't get this area, you go home, redo. Okay? So make sure you go home, redo. Don't just see it. Okay? If you see it, you learn nothing. So make sure if you got this wrong, you go home, make the correction. So you got that area. So where is our common area? The feasible region, where is it? Do you get the area? Anybody? Just tell me where the area is. Where is it?
The shaded area.
The shaded area, where is it? On the right or on the left or up or down?
Up on the right.
Right.
On the right. Okay. You see the graph here. Will be the area intersecting of this line up to that point.
But we have to
boundary
put
by that line.
the third inequation, right?
Betul tak? Huh? Oh, we just consider 2 first. Okay. So actually there are 3. So we come back to 3 afterwards. Okay. So consider these 2. So what you have now is the feasible region. Okay. Tadi saya punya internet hilang kejap. Alamak. Okay, so we go back to our
Sir, you have poor internet connection, sir.
apa dia?
Tadi internet tak ada tadi.
Itulah internet tak ada. So sekarang sharing dia hilang internet dia hilang sekejap. Aduh, pening lah macam ni. Takut saya punya recording nanti dia tak cukup. Tak habis. Okay, sekarang dah okay. Sharing dah nampak?
Yes, sir.
Okay, good. I'm sorry for that one. Internet ni biasalah. Malaysia punya internet. Okay, so you have this thing here. Okay, feasible region, open feasible region. Now, actually, you know, I didn't see the third equation, but it's good. I didn't see that. So that we have the two things. Actually, the other equation is what? There is another equation. The other equation is x bigger or equal to 12. So you know what? You change it because you
Sir?
have, yeah.
Sir, to show graph is contain marks.
Of course, no? Because for this one, this is the graph. Okay, for this topic, it's about the graph. Everything is on the graph. So
Yes.
the main point will be the graph. Without the
Yes.
graph, then we cannot show the solution. Then there is nothing that we can do. Okay, so for this
Yes,
topic,
Yes,
the graphical method. So it's about the graph. Okay, so make sure we should be able to draw the graph and then determine the inequalities. Okay, so if you cannot do that now, you have to go home practice. Okay, it's not difficult because we know already equation. Okay, so once you know equation,
Yes,
this is extension. Yeah, nothing much. So what I want you to do, if you put x bigger or equal to 12, you will have open area as well. So you change the inequality, you make it x less or equal to 12. So you now introduce the third inequality. So you got number 1, you got number 2. Now number 3, you do this, x less or equal to 12. Okay, so if you do that, I want to see you will have a closed or a bounded feasible region. Now, show that we will get that bounded area.
It is still an open area, sir.
Hah? Still open? Okay, tengok balik. Kemana? X equal to 12. X equal to 12. Is it horizontal line or vertical line?
Vertical.
Vertical.
X equal to 12, vertical line. So do you have a bounded area or you have do you have a bounded area or you have an open area?
Bounded between 10 and 15.
Bounded, yeah. Because, you know, x equal to 12 will be somewhere here. X equal to 12 here. But I want to change from bigger than becomes what? Less than. You see, I put the inequality less than. Okay, don't follow the book. If you follow the book, then you get an open area on the other side as well. Okay, so now you change it to less than. So what you will get, this would be our equation. X equal to 12. Less than, where is it? Left or right?
Left.
Left lah. Okay, yang ni tak payah test point, tak apa. Okay, you got there. So therefore, our feasible region will be the area bounded by that point to the along that line, up to that point, up to here, to there. So you got a triangular area. So that is our feasible region. So that is bounded feasible region. Okay. Any question? All right. So that is open, closed, bounded, unbounded. Now we introduce the other inequalities. Let's say we have x bigger equal to 0, y bigger equal to 0. So here you start with the equation x equal to 0. And of course here y equal to 0. Now x equal to 0, which line are we talking about? X equal to 0, where is the line?
The vertical one, sir.
Is it the vertical or horizontal? The vertical, okay?
Vertical.
Y-axis. Okay, this is all the points x equal to 0. Okay, x equal to 0 meaning x is 0. y can be all the values of y. So that will be the line. Okay. So this is x equal to 0, the y-axis. Now x bigger than 0. Where is it? To the right, or
Right.
to the left? To the right. Okay. X bigger than 0 will be like right. So I just want to see, x bigger or equal to 0 is the area on the right. Okay, second, you got the other inequality, y bigger or equal to 0. So you start with y equal to 0. What line is y equal to 0?
Horizontal.
Horizontal, the x-axis. Okay, so that is y equal to 0. All right, y equal to 0. And then y bigger than 0 equal to 0 is all the points up there. All right, so when you take into account x bigger or equal to 0, y bigger or equal to 0, then we are only talking about this quarter. Okay, this quadrant. You call it quadrant number 1, first quadrant. Okay, so that is first quadrant. So we only consider the first quadrant. So when you do this, I will do this when you consider application, because application, the value of the variables that is relevant is positive. Okay, negative value variables we don't consider. All right. So x equal to 0, y x bigger equal to 0, y bigger equal to 0. It's relevant only on application. When you take that into account, then we are only considering that first quadrant. So anything feasible region beyond that area will not be counted for. Okay, all right. So if you go back to our example, if you take into account x bigger equal to 0, y bigger equal to 0, then if I exclude the line x equal to 5, x less or equal to 5. So now take out what is, take out this one. Then you include only the x bigger equal to 0 because I want to see the difference. So now, now our system would be 1, 2, 3 out. So now this is our number 3. X bigger equal to 0, y bigger equal to 0. So what is our feasible region? What is the difference between this feasible region and when you have only 2 inequalities? When you have the 2 inequalities, our feasible region was this area. From here up to that point, all the way down here. Okay, that was the feasible region. Now you include x bigger equal to 0, y bigger equal to 0. What is the feasible region now? Okay, spend 1 or 2 minutes. You put in the x bigger equal to 0, y bigger equal to 0. And then what is the feasible region now? So take out the x less or equal to 12. All right, disregard that one. Because I want to see, I want to see the effect of x bigger equal to 0 and y bigger or equal to 0. Okay, so what is our feasible region now? Anybody got it?
Quadrant 1.
It will be quadrant 1. Okay, it will be bounded by this line up to that point, that line up to here. But when you reach here, it is now bounded by what? By y equal to 0. It will not go down. Okay, so our feasible region now is this area. So the difference would be only now, your solution is on the first quadrant. Of course, x bigger or equal to 0 is also included there, all right? Because it's that area. So the thing that I want to emphasize is that the feasible region will not include this area anymore. Okay. Well, solution will be only there. Any question? All right. Okay, good. And now what I want to do is we want to move on and look at application. So application of the system, which also cover the inequalities. we will consider one application. So go to the book. I would like you to read this example. 4.1, okay, application example number 5. Example number 5. So I would like you to read, okay, example 5. Now, when you read, when you come in with application, there are a few things that we will do, okay? I will discuss that afterwards, but I want you to read. And then I just want you to summarize, okay? Summarize the information. Now, what is the problem about? Okay, so what is it about? Okay, what is it about? So don't worry about the numbers yet, okay? Don't worry about the numbers yet. So just read what is it about? What are they doing? What they want to do? Okay, what is it? Okay, so I give you a few minutes to read that example. Okay, got it? Okay, let us just summarize. What is the problem about? Okay, give me the points. So here, summarize. Okay, what is it about?
It's all about to plant corn and soybeans.
So
in the
about
farm.
to plant corn and soybean. Okay, what is the name of the company?
Yeah.
What is the name of the company? It's a co-op. Okay, you have a farm co-op, and you want to plant corn,
Oh,
soybean. Okay, what else do we know?
They need to use fertilizer.
To plant all these things, what you need is what? Fertilizer. What else?
land
Land,
and labor.
labor. So here you'll see the relationship between the product, corn and soybean. And here, if you look at this thing here, what is this? This is the input. Okay, the input. The labor, land, fertilizer. Okay, which are needed in order for you to produce the plants, which are corn and soybean. So basically, this is the situation. Okay, now when you want to do the inequalities, you have to have the general form. We are talking about what? We're talking about A1x plus B1y. You know, it can be bigger or equal to C, or it can be less or equal to C. Okay, I put here bigger than now. Okay, it can be less than, of course. I put bracket here, it can be less also. And then you can have A2x plus B2y less than or can be bigger than C2. So you can have 2 at least, all right? You can have more, or you can have another a 3, a third one, okay? So from this information here, you want to come up with the inequalities. So what we want to do from here is, from this information here, we are going to tabulate the information, make it into a table. You want to relate, okay? You want to relate all this information. In other words, you want to relate the corn, soybean, okay, to the inputs, to the fertilizer, land, labor, okay? Now, if you look at the inequalities, you have here the variables, X and Y, and here are the constants. So these 5 things will be the variables, X, Y, and it can also be the constants, the C, okay? So either one of these can be the constant, C1, C2, or C3, okay? Either of these can be constant, or they can be the variable, all right? So from the problem here, you need to identify which is which, okay? You have to identify which is which one is the constant. The constant, of course, will be the one that is limit. Okay, there is a limit. There is a limit. There is a given value. Okay, there is a given value. So you know that will be the constant. Okay, it's given value. All right, and the variable is the one that is changing. And normally, okay, normally this is what you want to find. The variable, the value of the variable is what you want to find. So you want to find, so the question may be, what is the amount of fertilizer that we need? Okay, or it can be how much corn and soybean can be produced. So from there, we will know what is the variable. Okay, so the variable can be determined by the thing that you want to find, the objective. And the constant, normally they will give the value. So you have the idea of how the constant is. All right. Okay. So that's how you formulate the problem. So now you tabulate the information, and then you come up with the inequalities. So based on the tabulation, you are going to relate the variables and the constants, and then you come up with the inequalities. Okay. All right. So now we look at the numbers. Okay, you look at the numbers. So if you read more, what does it say? What does it say in terms of, you know, the relationship between the products and the inputs? What does it say?
The number of acres of each crop is limited.
That's number 1. Number 2. Okay, what does it say in terms of, you know, the relationship between the corn, soybean, and the inputs? What does it say? Cepatlah. What does it say? I don't think the problem is 1 page. It's just one paragraph. So what does it say in terms of relating, or you know, how to relate the corn and the soybean to the fertilizer, the land, and the labor?
So per meter quadrat of corn, they need 9 gallons of fertilizer.
So that is the next round of information. From there, you can do the relationship. All right. 1 acre of corn require what? Require 9 gallons of fertilizer.
Yeah.
And then what? 3/4 hour of labor. All right. And of course, there is land. So what you do here is we tabulate. So you have your corn, and then you have the soybean. All right. You have the labor. We go by the book. Fertilizer. Okay. They use fertilizer first. Here you got the fertilizer, and then you got land. No, labor. And then here I put the land. All right, because land is 1 input. Now corn. They say here each acre of corn. So corn here is not the kilogram of corn. It's what? It's acres of corn. Okay, that means the acres of the land that you grow for the corn. Is that right? So from here, you have per unit information. So here for 1 acre of corn, what do we need? I need 9 gallons of fertilizer. So you table it. Okay, so that we can come up with the inequality. Otherwise, we will be confused. And 3/4 hour of labor. So now it's systematic. Okay, you have a system already, the numbers and the constants and the variables. After this, we will identify which is which. And then you got the soybean. What is the requirement? 3 gallons of fertilizer and how much hour labor? 1 hour.
No.
Okay, and then what are we given? Okay, what is next? Okay, read more. After that sentence, what are we given?
We are given the limitation of gallons, available gallons.
So now you are given available at most 40,500 gallons of fertilizer. So fertilizer, you are given the amount 40,500 gallons. You see at most. Now at most, what does it mean? At most means that is the largest. Okay, that is the highest. Okay, it can be what? It can be lower. So what is it? Is it bigger than or equal to or less than or equal to?
Less than equal to.
Less than or equal to. Okay, because that's the largest value, it can be lower. Okay, so at most, less or equal to. And also you are given how much is the limit to the labor? 5 to 50 hours. Also at most, so less than. All right. Now, what is about land? You are given only how much land do you have?
We have 60,000.
6,000 acres. Is that right? 6,000 acres. Now, 6,000 acres, what you have? Can you have more than 6,000? No. But it can be less. All right. You can grow less than 6,000, but you cannot grow more than 6,000. So for the land, they didn't say at most 6,000. They have 6,000 acres of land. That's it, right? But if you want to use it for inequality, then you just use common sense. Okay, that is the highest value of the land, 6,000 acres. You cannot have more. Okay, so you can grow less than that, but not more. So be less than as well. Okay, so from here you have the limit. So when you have the limit, then you know the constants are what? The constants are the fertilizer, the labor, and the land. So therefore, what is the variable? What are the variables? The variable is a measure of the corn and the measure of the soybean. And of course, like I said earlier, you can also determine the variables by what? By the objective of the problem, what you want to find. Okay? This example, it doesn't say. So if you have a proper problem, they will give you that. So now you have already identified the variables and the constants. Now, what about land? They didn't say anything. Now, the land, the allocated land will be on what? Will be corn and soybean. So we just put here 1, 1. Okay? So 1 and 1, that means X and Y. So from there, you have X and Y. So let us be more specific on the X and Y. So the X and Y is not just corn, it's what? It's the number, it's the amount of land grown corn. The number of acres of corn. Okay, the number of acres of corn, or the quantities of corn in acre. Right? So the number of acres of corn. Or you can put here just simply corn. Okay, corn in what? Not in kilogram, in acres. That means the area of land that you grow corn. And Y is the number of acres of soybean, or the soybean in acres. So from here, you have the variables, x, y, and then I have the constants here. So now we will have the inequalities. So in order for you to come up with the inequalities, so therefore we have to make the tabulation correctly. All right. So you have here number one, you will get the inequality number one. That means for the constant, which is the fertilizer. So you call it number one. We don't have to call it, you know it's a fertilizer. So what is it? It's 9x plus 3y less than or equal to 40,500. So call it number one. So that is the first column of the table. So if you look at the table, it will be this one. Okay. Now you have the labor. So labor, what do you have? I have 3/4 hour, 3/4 hour, 3/4x plus y less or equal than 5250. So that will be our number two, and that is on the labor. Okay, and then on the land, what I have x plus y. The area that you grow land, you grow soybean and corn must not exceed 6,000 acres. So that is our number three. And of course, x bigger or equal to 0, y bigger or equal to 0. Now in application, you don't need to specify this one because we know, okay, it is already built in. Okay, we know in application the negative value of the variables are not relevant. So we know it is only on the first quadrant. So you don't have to specify x bigger or equal to 0 or y bigger to 0. Of course, if you do, that's fine also. But if you don't, it is not necessary. Okay, because we understood already, application that will not, or that is already being included. Okay, so you have the three inequalities here, and then you have identified already the variables, and then you have the constants. So what you do next is, of course, find the solution. Okay. All right. Any question on this? Okay. Everything is given in the book. All right. The answer is given on the book. The thing is given on the book. Now, I don't want you to just look at the book. All right. The book will only serve for you as your guideline. I want you to do this as a homework question. Do on your own. All right. Do on your own. You do it, and then you check the book, whether you are right or you are wrong. If you are wrong, you redo. Okay. Don't just look at the book. Look at the book. It's very easy, you know. But there is no learning. Okay. So I want you to do on your own. Of course, you discuss with your friend, but make sure you do it on your own. All right. If you have a problem, you ask your friend, or you ask me. Okay. You ask in the WhatsApp. You can discuss with. Now, when you discuss, you may also discuss with your friends, not in your group. Okay, so you can discuss with anybody, not in your group. Of course, your primary discussion classmate is your group member, but you can also discuss with other people. Okay, okay. So any question on that one? So I want you to finish this up. All right, finish this up. So I hope you got the feasible region. So on Wednesday, you are going to look at the linear programming problem proper. Based on it, you will find the solution which is relevant to the linear programming problem. Okay, yeah. Yes, anything?
No, sir.
Okay. All right. Any question, anything, any comment?
No,
Okay.
sir.
Okay, if there is nothing, that's good. Oh, 5 na orang dah keluar. Now, earlier I have 57. Of course, the actual number is about 69 people, 69. So 57 today, I have about 12 people missing. That's a big number, And then before 4 people left, it's okay. But I think the number of people absent is more than 10. That actually big number, So I don't know. I already discussed about this with you. Don't make absent as a habit. That will be a problem. So I will see you again next Wednesday. Not next Wednesday. This Wednesday. Okay. This Wednesday. I hope I can finish up this topic, by Wednesday, because this topic is very short. So let's see. All right. Okay. You don't have anything? Okay, good. So yeah. I need to give you some questions on 4.1. I give you already that example. Okay. I want you to do a few more. Okay, do a few more on the questions. I want you to do number 7. Okay, the graph is given, but I want you to draw a proper graph. Okay, so number 7, and then you do number 8. Okay, for this question. Anak siapa nangis tu? Woi, anak siapa nangis tu? Hah? Adik ke anak tu? Okay, for question number 8, yang ni tak payah. Okay, buang. X bigger than 0, Y bigger than 0 tu buang. Yang number 7 tu okay. So we just want to see the possible result. Okay, so I give you only 2 questions, 7 and 8, and then the one that I give you example number 5. 7 and 8, bukan 7 and 8, silap. 7 and 10. Sorry. I was looking at question number 10, not question number 8. Okay, so that should be number 10. Okay, so let's check. Okay, all right, I'll see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam. Thank you,
Thank you,
Doctor.
Thank you, sir.
Okay, thank you.
Thank you, sir. Thank you, sir.
Thank you, sir.